Bamboo is one of the fastest growing and most versatile plants on Earth, capable of becoming flooring, furniture, paper, textiles, packaging, tools, and even structural materials. Yet behind its simple green stalks is a carefully managed industrial process that turns raw grass into durable everyday products used worldwide. What grows silently in forests and plantations is harvested on precise schedules, cut with specialized equipment, treated against pests and moisture, broken down into fibers or strips, and then reshaped through heat, pressure, chemistry, and machining. Bamboo may look natural and simple, but turning it into reliable products requires planning, timing, and factory-level precision. And today on the How Factory, we're going inside bamboo farms and processing plants to see exactly how bamboo is harvested and transformed into everyday products at massive scale. Bamboo has been used by humans for thousands of years, especially in Asia, where it became a cornerstone of construction, tools, and daily life. Ancient builders relied on bamboo for scaffolding and housing, while craftsmen turned it into baskets, paper, weapons, and musical instruments. Entire cultures evolved techniques around bamboo because it was abundant, strong, and renewable. What makes bamboo unique is that it's technically a grass, not a tree, which means it regenerates rapidly without replanting. Modern industry has taken advantage of these natural properties, scaling bamboo production into a global supply chain that balances agriculture with manufacturing and sustainability. The process begins at bamboo plantations or managed forests. Bamboo grows incredibly fast, with some species capable of growing over a meter in a single day under ideal conditions. However, not all bamboo is harvested immediately. For most industrial uses, bamboo must mature for 3 to 5 years to reach optimal strength and fiber density. During this time, cellulose content increases and internal moisture stabilizes. Farmers carefully track planting cycles, tagging sections of bamboo by age so only mature culms are cut. Harvesting too early produces weak material, while harvesting too late reduces flexibility and increases cracking and brittleness. Harvesting is typically done manually or with light mechanized tools. Workers cut bamboo close to the ground using saws or machetes, leaving the underground rhizome root system intact so new shoots can grow. This selective harvesting method allows bamboo forests to regenerate continuously without clear-cutting, unlike traditional timber operations. Once cut, bamboo poles are trimmed of branches and leaves on site, then bundled for transport. Speed matters at this stage because freshly cut bamboo contains sugars and moisture that attract insects and fungi if left untreated for too long. After harvest, bamboo is transported to processing facilities where it undergoes its first major transformation. Raw bamboo is not immediately suitable for most products. It must be treated to prevent insect infestation, mold growth, and internal decay. One common method is soaking or pressure treatment. Bamboo poles are submerged in water to leach out sugars or treated with boron-based solutions that penetrate the fibers and deter pests. In industrial facilities, bamboo may be placed in pressure tanks, where preservatives are forced deep into the material. This step dramatically increases lifespan, especially for construction, furniture, and outdoor uses. Once treated, bamboo is dried. Drying is critical because bamboo contains a high moisture content that can cause warping, splitting, or fungal growth if removed incorrectly. Drying may happen naturally in shaded, ventilated areas or inside controlled kilns. Industrial kilns use carefully managed temperature, airflow, and humidity to reduce moisture gradually. Proper drying stabilizes the bamboo, equalizes internal stresses, and prepares it for cutting and bonding operations. From here, bamboo processing splits into multiple paths, depending on the final product. For products like furniture, flooring, and boards, bamboo poles are cut into strips. Machines slice the round poles lengthwise, flattening them into rectangular strips. These strips are then planed and sized to uniform dimensions using precision equipment. At this stage, defects such as cracks, insect damage, or uneven fiber density are removed. Uniformity is essential for later bonding, strength, and appearance. For bamboo flooring and structural boards, the strips are arranged into layers and glued together. Industrial adhesives are applied evenly, and strips are stacked in specific orientations to control grain direction. Some products use horizontal grain layouts for a traditional look, while others use vertical grain layouts for increased hardness. The laminated bamboo is then pressed under extreme pressure in hydraulic presses. Heat may be applied to accelerate curing and improve dimensional stability. This process transforms flexible bamboo strips into dense, solid panels that behave more like engineered wood. Many bamboo products undergo carbonization, a heat treatment that darkens the material and alters its internal chemistry. Carbonization involves heating bamboo in controlled environments, caramelizing sugars and producing a deeper, uniform color. While this process improves appearance and reduces susceptibility to insects, it can slightly reduce mechanical strength. Manufacturers carefully balance carbonization levels depending on whether strength or aesthetics are the priority. Once laminated and treated, bamboo boards are machined into final shapes. Flooring planks are milled with tongue and groove profiles so they lock together during installation. Furniture components are cut, drilled, and shaped using CNC machines. Edges are rounded or beveled for comfort and appearance. Surface finishing follows, including sanding and coating with protective finishes that resist moisture, abrasion, and UV exposure. These finishes allow bamboo products to survive in kitchens, bathrooms, offices, and high-traffic environments. Another major processing path is bamboo pulp and fiber production. For paper, packaging, and molded products, bamboo is broken down into fibers rather than used as solid material. Bamboo is chipped into small pieces and fed into pulping systems. Chemical pulping uses alkaline solutions to dissolve lignin, freeing cellulose fibers. Mechanical pulping relies more on grinding and pressure. The resulting pulp is washed, refined, and formed into sheets for paper products or molded into packaging shapes. For bamboo textiles, fibers undergo further processing. Bamboo pulp is dissolved and extruded through spinnerets to create continuous fibers that can be spun into yarn. This process produces soft, breathable fabrics, commonly marketed as bamboo viscose or bamboo rayon. While the raw material is bamboo, the transformation involves advanced chemical processing, and modern factories carefully manage waste streams and solvent recovery to reduce environmental impact. Bamboo is also increasingly used in engineered construction products. Laminated bamboo beams, panels, and structural elements are manufactured by aligning fibers and bonding them under pressure. These engineered bamboo products can rival hardwood and even steel in certain applications. When designed correctly, bamboo's strength-to-weight ratio makes it suitable for sustainable buildings, bridges, and modular structures. Throughout manufacturing, quality control plays a central role. Bamboo varies naturally, so factories test moisture content, density, strength, and bonding quality at multiple stages. Finished products are inspected for dimensional accuracy, surface defects, and coating quality. For construction-grade bamboo, load testing may be performed to verify performance under bending and compression. Sustainability is one of bamboo's biggest advantages, but it still requires careful management. While bamboo grows quickly, processing consumes energy and chemicals, especially in pulping and textile production. Modern facilities invest in closed-loop water systems, waste treatment, and energy recovery to reduce environmental impact. Bamboo waste such as sawdust, chips, and offcuts is often reused as fuel, filler material, or compost, ensuring minimal waste. What makes bamboo manufacturing remarkable is how a hollow grass can replace traditional materials in so many roles. Its natural structure provides strength and flexibility, but only through controlled harvesting, drying, treatment, and engineering does bamboo become reliable for global markets. Every step is designed to stabilize a living material and turn it into something predictable, durable, and standardized. From green stalks growing in dense groves to bundled poles heading into treatment tanks, from sliced strips pressed into flooring to fibers spun into soft fabric, bamboo's journey is a blend of agriculture and industrial precision. It is renewable by nature, but refined by machines. And that is exactly how bamboo is harvested, treated, processed, laminated, pulped, molded, finished, and shipped, transforming one of the world's fastest-growing plants into everyday products used in homes, offices, and industries everywhere. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the farms, factories, and systems behind the materials we use every day.